Okay, this video is part of classwork 223. I'm going to be showing you some stuff, and then of course I want you to do a screencastify of your voice over this just to practice some of this stuff. But here we go. You need to know that when you have two parallel lines, these are called parallel lines. These two lines never ever touch. They never cross, like railroad tracks, never touch. Of course, if you have railroad tracks that do touch, you would have people die. Railroad tracks are parallel, they never touch. Of course, when you cut those parallel lines by this line called a transversal, you need to know that you get all these angles that have these unique properties. And of course, your eyeball can tell you. If you're looking at these, all of these angles are the same exact opening. You could see that with your eyeball. If I measured that with a protractor, it would be the same degree. The other angle I could see, which is way bigger, I have a bunch of those that are the same size too. You need to know that just with your eyeball. You could see that. And of course, if we gave you numbers, we need you to know if this was 110 degrees, the angle right across from it would be 110. If, of course, that's 110, the angle right next to it, what we call supplementary, which means add up to 180. If I know half, the other half, of course, would have to be the part that makes up 180. 110 minus 180, this angle would have to be 70. And of course, if that's 70, then this one right here is 70. And if that's 70, then this one right here is 70. And if that's 70, this is 70. And of course, if this is 70, the one right next to it would have to be what it takes to get 180. This angle would be 110. This angle right across from it, 110. So again, your eyeball can see, and if I gave you numbers, you'd be able to plug them in. But what I want you to practice on today is these technical names. So let's get rid of all that stuff. All right, good enough. We'll leave those. What I want you to see is we ask you to list a pair of vertical angles. You could pick any pair you want. Just make sure that they are right across from each other vertical. And know that if you pick a vertical pair, they're always equal. So here's a pure vertical pair right here. That would be angle 6 and angle 7. That is a pair right exactly across from each other, vertical. So if I wanted a vertical pair of angles, here's a vertical pair, 6 and 7. Of course, there are many more. These are always equal. Whatever one angle is, the other angle is also. All right, the next term is corresponding. And corresponding means angles that are not on the inside. We have a special name for inside angles. We call those interior angles. Corresponding angles are not both on the inside. You have one on the inside, but then you have another one on the outside that's equal. So those are two corresponding angles. They're not on the inside of the parallel lines, but they're equal. One inside, one on the outside. If I did another pair of corresponding, if I could get rid of that. Here's another pair of corresponding. This 6 right here on the inside, and then this 1 down here. One on the inside, one on the outside that are equal. Here's another corresponding pair. How about 3 and 7, or 6 and 1, or 4 and 8? But again, not both on the inside, both clearly equal, but one on the inside, one on the outside. So I'm going to pick 7 and 3. And again, these are equal. always equal. Whatever angle 7 is, angle 3 is. And of course, one is on the outside, one's on the inside. Now we have these interior angles, which means these angles on the inside of the parallel lines. That's what we call interior. Alternate means one on one side of the transversal and the other one on the other side of the transversal. Alternate means on either side of this transversal line. And again, they are always equal. So if I pick those two, no matter what, I know they would have the same degree opening. So how about 5 and 4? Those are clearly alternate interior, which is equal. If I wanted another pair, of course I could have picked another pair. I could have picked 6 and 3. And those two angles are equal to each other. Alternate interior, alternate sides of this transversal line cutting through, one on one side, one on the other. Alternate interior, always equal. Alternate interior, always equal. All right, the other one is what we call same side interior, same side of that transversal line inside the parallel. And of course, those are not equal, but if, as you've been practicing, those are supplementary. Those would plus together to give you 180, because of course 5 is equal to 4, and angles right next to each other, which we call straight angles, those are always supplementary, equal to 180. But again, if I want a pair of same side interior, pick a pair of angles on the same side of the transversal, like maybe 5 and 3. That would be a good pair, 5 and 3, same side interior. And then the last one is, of course, straight angles. Any angles that are in a straight line right next to each other. Straight angles. Here's a pair of straight angles. Here's another pair. Here's a pair right here. But again, straight angles are always that characteristic right next to each other, sorry, that add up to give you 180. Straight angles. And of course, any pair of straight angles that have to be right next to each other. So I'm going to just go 4 and 1 just for an example. And again, what I'd like you to do is try to screencastify your voice talking about my examples in your own way. Copy and paste that link onto your Google slide. Good luck.